Hi everyone, today we're going to start chapter 2.
First, we're going to start with 2.1 graphs.
So 2.1 graphs. This is called a rectangular coordinate system. So the horizontal axis here, and we have the vertical axis here. Horizontal axis here, normally we label that x-axis, and the vertical axis here, we label that y-axis. These two axes here intersect at this point is called the origin. And these two axes divide the whole plane into 4 quadrants. So quadrant 1, 2, 3, and 4. Next, we talk about graph pair data. Okay. Everything will deal with quantity that are related. For example, the money we earn depends on the number of hours we work, right? And the sales tax that we pay depends on the price of the item purchased. And over here, this table over here actually has this height of the rocket. It depends on the time over here, okay? So this is actually a table that we call the height of the rocket at a certain time, okay? So over here, we have a toy rocket here. So at time t equals 0, the height will be 0. And then as the time go on, and then the height is going to increase. But once we reach a maximum height, and then it's going to fall down again. And then eventually it's going to hit the ground. Then the height is going to become 0 again. So this is the table that we call those data, the data of the height of the rocket. Okay. And you can see that from 0 to 3 seconds, looks like the height is increasing. It's getting higher and higher. But after 3 seconds, looks like the height is going to decrease to 0, which means it hit the ground again. Now we can use this time over here as the first coordinate, using the height of the rocket here as the second coordinate. And then we get an order pair, and we can plug in those points. So right now we can plug in those points, we get those corresponding points over here and here. And then we can connect the dot and graph this. As you can see here, from 0 to 3 seconds, the height of the rocket is increasing and reach this high, and then after 3 seconds, the height is going to decrease and go down to 0 here, okay? You can also use the graph to make observation about the height of the rocket and other time. For example, looks like this one, 1.5 seconds. If I want to find the height of the rocket, I can go up, hit the graph, and find this point, and look to the side and find the height of the rocket, which is about 108. So we say that the height when the time is 1.5 seconds here, the rocket is about 108 feet high. Number 3, we're going to talk about how to read the graph. Okay. Now over here, this is a graph for the water level of a reservoir. Okay. Here the storm begin here at 0. Okay. So this is before the storm begin, and then after the storm begin, and then here the storm ended here. Okay. Okay, so this is a graph that shows the water level of the reservoir before, during, and after the storm. Okay. On the x-axis, 0 represents the day that the storm began. So this x-axis, so this is 1 day after the storm began, 2 days after the storm began. Okay. What about the vertical axis? The y-axis here, 0 represents the normal water level. So if it's 0, then that's the normal water level. Say here, the y coordinate is 0. So that means the water level was normal over here. Okay. Now the question over here, in anticipation of the storm, operators release water to lower the level of the reservoir. By how many feet was the water lower prior to the storm? So prior to the storm, okay, so the storm began here. The water level, so here is 4 days before the storm began, and the water level was 0, which is normal, okay? And then when the storm began, looks like the water level is -2. So the operator actually released water and lowered the water level to -2, okay? So when the storm began, okay? So the answer here is the water level was lower to -2 prior to the storm, okay, prior to the storm. the second question. After the storm ended, on what day did the water level begin to fall? Well, the storm ended at here, day 3 over here. Okay, so looks like the water level here is going to stay the same over here, and then after that, it's going to fall. So this day here, the water level began to fall, which is 5 days after the storm began. 5 days after the storm began, the water level began to decrease. So the last question, when was the water level 2 feet above normal? Well, the water level is on this y-axis. So we locate 2 feet over here, and we want to find the corresponding day. So we look to the side and hit the graph. Looks like I hit the graph here and also here. And the day corresponding days over here is day 2 and also day 7. So the answer here is on day 2 and day 7. After the storm began, then the water level would be 2 feet. Okay, so that's the answer here. 2 days and 7 days after the storm began, the water level was 2 feet above normal. Notice that over here, we used X to label this horizontal axis and Y label the vertical axis. Sometimes it's not necessary just to use X and Y to label the horizontal and vertical axis. For example, this one, in this example, we label the horizontal axis here D, stand for the day, number day, and the vertical axis here C, and stand for the cost. Okay, the cost of renting a ski equipment package. Okay, notice that over here, those here are open gap right here, and then on this is solid dot over here. Okay, so use the graph here to answer the question about the rental cost of a ski equipment package. Okay, find the cost of renting the equipment for 2 days. So 2 days over here, so we locate 2 on this d-axis, so 2 days, and we go up and hit the graph, and we look to the side, and it looks like it's $80. So the answer here is going to be $80 for that one. The second one, find the cost of renting the equipment for 5.5 days. So 5.5. So here is 5 and then and a half. So it's in the middle of 5 and 6. So we're going to go up and hit the graph and hit over here. And then you look to the side. The corresponding cost here is $160. So that will be $160. Okay. The next one, how long can you rent the equipment if you have budget $120 for the rental? So that is the cost right here. Okay. So that's your budget. Okay. So we're going to locate 120 on this C-axis, the vertical axis right here. Okay, locate that. And then we hit the graph over here, and we go down and find the corresponding D over here. And looks like is going to be, the corresponding D here will be greater than 3 and then up to 4. So if you rent the package, the ski package, more than 3 days, and including up to 4 days, then you're going to pay $120. So if you have a budget of $120, you can rent the package 3 to 4 days. Now, because this is an open gap here, so the 3 is not included. So it's more than 3 days, and then over here is a solid dot here, so up to and included 4 days. So more than 3 days and up to include 4 days over here. Then you pay $120. Okay.